The teacher of the third grade class in Roosevelt Elementary School has 3 prizes to give away to her 13 students. She tells the students to put their names on a slip of paper and pass the paper in to her. She then will put the names into a hat and draw them out. The first name she draws will win a large stuffed teddy bear. The second she draws will win a 1-pound chocolate bar. And the third name she draws will win an eraser. I would want the chocolate bar. But let's see what's going on here. The question is this a permutation or a combination, and why? Now, honestly, I don't care myself about permutation and combination. It's not important. The way I've instructed this topic, I'm not using those words, but I know those words are commonly used in the K through 8 curriculum, so I want you to be aware of them. I really prefer the method I've taught you that I learned from the Australian guy, that basically where you just put them in order. It's just orderings of letters in a word. But anyway, so here most people do this using these words, permutation and combination. So let me tell you what they are so you'll know for when you're teaching in the K through 8 curriculum. A permutation, order matters. Order matters. And in a combination, order does not matter. That's what people mean. That's what these terms mean. Now, for example, what if I was going to pick 3 students in my class at random, and I was going to give the first one a $20 bill, the next one a $10 bill, and the third one a $5 bill? If I was going to do that, if I was going to pick 3 names out of the class at random, and I said, hey, the first name is going to get a $20 bill, then the 10, then the 5, and your name was one of the 3 that was picked out, would you care what order? Would you care whether you went first, second, or third? Yes, you would. Because first place gets more money than third place. You see, order matters when the objects are different, when the prizes or the objects are different. Whereas, let's compare. What if I said I'm going to pick 3 people out of my class, 3 students at random, and they're all going to get $10. $10, $10, $10. And if your name was one of the 3 picked, would you care what order? No, you wouldn't care. Order would not matter. When does order not matter? When the objects are all the same, or the prizes are all the same, then who cares what order? So that's the distinction here between permutations and combinations. Permutations, order matters because the prizes are different. We care what order something's done in. So that would be like picking a president, a vice president, and a secretary for a club. Whereas over here, this would be like picking 3 committee members, because they're just all committee members. It doesn't matter who's first, second, or third. They all have the same level, same prize, same object. Whereas over here, president, vice president, secretary, those are different. So the order matters. That's what we're talking about. So you know those terms when you teach in the K through 8 curriculum. I did not solve the problems, the counting. This whole section 9.4 is called counting problems. I showed you a new way, which I think is greatly superior, that I learned, like I said, from a gentleman in Australia. I learned how to do it without using the word combination or permutation, without really worrying about order mattering or not. I think it's way better. I'd really encourage you to teach younger folks that way. But you also might have to teach them these words, permutation, combination, just because it's typically part of the K through 8 curriculum. It's historically been taught with permutation and combination so long that you are kind of probably stuck to teaching those words at least. All right, so getting back up to this problem then. So she's drawing, the first name gets a large bear. The second name gets the chocolate bar. That's what I'd want. The third name, the eraser. So the 3 prizes are different, aren't they? So does the order matter? If you get first prize, first pick or third pick, does it matter? Yeah, it does. You get something different. Order matters on this problem, which means it's what? It's a permutation. Order matters. So it's a permutation. It's a permutation because order matters on this one. Order matters. Now, how many ways are there to choose 3 kids out of 13 for the prizes? Now, here's where I'm just going to do it with the new way I taught you, which I think is much better. And that is, I'm saying, well, all we're really, I'm not even going to think about all their crazy stuff. I'm going to say we have 13 kids in the class. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 kids in the class. And we're going to pick somebody to get the bear, the T for the teddy bear. Somebody's going to get the chocolate bar. That's the best. Maybe chocolate bar right there. And somebody else is going to get the eraser. That's a bummer. All right. And then everybody else is going to get nothing, 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 right? So we're really saying, what are all the ways to put those in order? What are all the ways you can order 13 letters? So we have, let me come over here, we have 13 letters. There's 13 students in the class. And we have what? 1 teddy bear, 1 chocolate bar, 1 eraser, and 10 ends. So you remember the formula, right? It's 13 factorial over 10 factorial, and you don't even need to put the 1 factorials because they're not repeated. It's just going to be 13 factorial over 1 factorial, or over 10 factorial. So that's going to be 13 times 12, I don't know what I'm doing there, times 12 times 11 times 10 times 9 times 8, etc., over 10 times 9 times 8, etc. So all these cancel. It's going to be 13 times 12 times 11, isn't it? It's all you have to do. It's easier than thinking about permutation combination. The answer is 1716. 1716. So it's all the ways to put in order 13 letters for the 13 kids where one of them is a T, whoops, and one of them is a C, oops, and, oops, sorry, I'm getting lost there. Okay, there we go.